Hi learners, welcome to my YouTube channel. So today we are going to do the part 1 of the topic functions. So now let us see from this one some of the first the introduction of this topic. So in the next video we can see the examples of it. So here what is actually function? So function is a relationship between inputs where each input is related to exactly one output. So this example we'll do it later. So every function has a domain and range. Actually, the function is denoted by fx, where this x is the input of it, and then any set of ordered pairs, that is called a relation. These are the pairs, so that is called a relation. So suppose we take this a as, always whenever we write the set we write the curly brackets. So these are the pairs. So means this, whenever we write this, means this is x and this is y. So what we have to see, the set of all x, these are the domains, and the set of all y, this is the range. So this is written over here. You can see the explanation, set of all x is called the domain and set of all y is called the range. And the domain means like same thing whatever I said, -1, 1, 2 and 3. It's written over here, and you have to write again this in the curly bracket, and because it's a set, and range of set A, that is 1. But actually whenever you write these numbers, it should be in the increasing order, that is 1, 2, 3 and 4. So that is 1, 2, 3 and 4. So now see here, this is the example given for the function. See here, now see, because as I told you here, the function is a relationship where each input is related to exactly that should be one output. So can you see, this is the input and this is the output. So can you see, this is exactly 1. So you have to look at the input and not the output. So this is exactly 1. So this is a function. Here you can see this 2. This is not exactly 1. So this is not a function. Each element of set A is mapped with only one element belonging to set B. So now we'll see what is one-to-one function. So one-to-one, see here, this is the input. Again here, this is just one-to-one. So this is set A and this is set B. And many-to-one. Many-to-one means can you see? For this one, there are 2. Again for this one, there are 2. So this is called the many-to-one function. Now we'll see the interval notation. So set of real numbers may be described in a variety, that is in the variety of ways. When it is inequality means you have to write here this way. When it is in the interval or it is bracket notation means you have to write this one, and graphically on a number line. So now when it is -3 to 5. So it starts from -3, but the ending here, this is 5. So this is the open dot and this is the closed one. So intervals that are infinite are expressed using, this is called the infinity sign. So we can say plus infinity to minus infinity. So here actually we don't write the positive one, we just write infinity, and whenever there is negative sign we write the negative infinity. So what do the square brackets indicate? Square brackets indicate that the end value is included in the interval. So can you see here? This is the end value is included in the interval, that is we write the square bracket. And round brackets indicate that the end value is not included in the interval. And the round bracket is always used at infinity and negative infinity. Whenever we write here negative infinity and infinity, always we use the round bracket. So now there are different types of parent functions. So that is, let us see one by one. The constant function. The constant functions are functions that are defined by the respective constant. For constant we write C. All constant functions will have a horizontal line as its graph. and contain only a constant as its term. See here, can you see this one? This is the horizontal one and this is the vertical one. So it will always, the constant function will have a horizontal line. So this is written y is equal to c, that means it's a constant. Then all constant functions will have all real numbers as its domain and y is equal to c as its range. So all the real numbers, that is as a domain. They also each have a y-intercept at 0 and c, that is where it is here, 0 and c, y-intercept. Now we will see the linear functions. Linear functions have x as the term with the highest degree, and the general form of this is given as, this is whenever you have in this form, y is equal to a plus bx, this is a linear function. And what we can see, whenever on the graph you draw it, always the linear function will have a straight line. Okay, so this is linear functions have a straight line as a graph. So can you see this graph? It has a straight line, and that is, you can write this as y is equal to x. And the parent function of linear functions is y is equal to x, and it passes to the, always it will pass, this is the origin. This is 0. That is the origin. It will always pass to the origin. And the domain and range of all linear functions are all real values. That means negative infinity to infinity. So even the domain is the same and the range also is the same, negative infinity to infinity. Now let us see the quadratic functions. Quadratic functions are functions with 2 as its highest degree. So can you say this one? This is there y is equal to x square. So you can see this. This is called the degree of it. When you write here x square, that is called the degree of it. So that has 2 as its highest degree. All quadratic functions written, that is it will be in a, like this is called the parabola. Parabola as the graph. And quadratic functions have y is equal to x square as their parent function. So now whenever you have like this parabola, means that is a quadratic function. And it will always pass here to this origin. So the vertex will be, this is called, whenever you write this parabola, this point is called the vertex of it, and the vertex will be always lying on the origin. So, and the domain of all real numbers, that will be, that is all real numbers, that is negative infinity to infinity, and the range is 0 to, so here can you see now, here this we write the square bracket, and the infinity here we write the round bracket. Now you will see for the cubic functions, means this, whenever you write y is equal to x cube, so this is called a cubic function. Share the parent, this is the parent one. Whenever you say this one cubic, we will write a y is equal to x cube. And the graph of y cube also passes, can you see, this is also passing to the origin. And the domain and the range is the same, that is all real values. Now we will see the absolute value functions. The parent function of absolute value means always you will write in this form. So y is equal to this absolute value, this is x. And it always has a V-shaped graph. So this is the V shape. And again this also, this V is going to pass to the origin. The V, this is the, whenever you write, this is the vertices as the actually at the origin. So now for this one, the domain is minus infinity to infinite, that is all the real values. Can you see here on this x, this is going here, and the range is here, means 0 to, it will go to infinity. So range is 0 to infinity. Now let us see the radical functions. The two commonly used radical functions, actually they are the square root and cube root. Can you see here? This is the square root and this will be the cube root. So they are called the radical functions. So parent function of square root function, that is going to be y is equal to root of x. So the graph will be this way. And whenever there is a cube root function, the graph is going to be this way. So the square root function, the domain is going to be, how is it? It's passing from here 0 to infinity. And the range is from, again, that also is from 0 to infinity. And in the cube root function, what we see, that it has all real values. Can you see? It goes from the -1 to the positive 1. That is, the domain is from negative to positive infinity. Again, the range also is the same. Now let's see that is the exponential function. So exponential functions are functions that have algebraic expression in the exponents. So in the exponent means, whenever I write here 3 raised to 3. So this is the exponent. So here they have in place of this, they have this one, the algebraic expression, that is, the parent function can you see here, y is equal to b raised to x. So this is an exponent. So parent function graph is when you go this one, you write it, and then whenever you draw a graph, you have to write y is equal to e raised to x. So we can see that it will never be equal to 0. So it is not going to be 0. And here domain is all real numbers, that is minus infinity to infinity, and range is 0 to infinity. And always what we can see here, the function is increasing. Can you see here? This is the curve. That means the function is increasing to the domain. Then the logarithmic functions. So they are the inverse of the exponential one. So that parent function can be expressed as y is equal to log of x to the base. In this one, what do you have? b raised to x. So here it is going to be b is here and the x is here. So it is the inverse. So you say y is equal to log of x to the base b. So this is the graph for the logarithmic functions. And here the domain we write as 0 to infinity, and the range is the all real values, that is minus infinity to infinity. So then the next one is the reciprocal functions. Reciprocal functions are functions that contain a constant numerator and x as its denominator. Whenever this is constant, so here you can see this is 1. That is a constant numerator, and x is the denominator. So this, whenever you see this, that this is a reciprocal function. And reciprocal function here, what you can see here, see this x and y can never be equal to 0. So here the domain and range are minus infinity to infinity, and this will be 0 to infinity. Now here I have given you the table over here, so that is easy to remember because there are many functions and this one, so how to remember the domain and range of it. So here there is a linear function. This is fx is equal to x, fx is equal to x square, fx is equal to x cube. This is fx is equal to absolute of x, fx is equal to root of x, fx is equal to cube root of x, that is the cube root function, fx is equal to 1 by x, that is the reciprocal function, and fx is equal to log of x to the base b, that is the logarithmic. So you can see for this one, for the linear, the domain is minus infinity to infinity. Again for the range minus infinity to infinity. You can have a look at it. And what you can see here, for the linear, cubic and the cube root, the domain and the range is the same, that is minus infinity to infinity. So hope that is clear. So when you look at this table, it will be more easier because we have many functions, and when we look at the description, sometimes you might forget it. So just have a look at this table also. So by this one we have completed today's work. Do like and subscribe to my channel so you get the notification of the other parts. Thank you.